Good morning, all. Today we are going to learn about parallel communication standards. In the parallel communication is a method through which we will send the data parallelly through multiple communication channels. And the main advantage of parallel communication standard is speed, because the data is sending through multiple channels at the same time. So higher speed can be achieved using parallel communication standards. And today we are going to study three protocols under parallel communication standards. The first one is ISA, then PCI and PCI Express. These three standards are once used widely for communication between computer and its peripheral devices. Now it is become obsolete and replaced by PCI Express standard. This is the outline of this session. Initially, I will give an introduction to parallel communication. And here I will discuss about the various advantages and disadvantages of parallel communication. Then I will move on to ISA standard. ISA standard is the first standard developed for processor to peripheral communication. And this ISA standard is replaced by PCI standard, and this PCI is short form of the peripheral component interconnect, and once it was a widely popular standard for communication between the processor and various peripheral devices. And then it is developed PCI X standard, and it was widely used in server application. Now all three standards are replaced by the newest PCI Express standard, which is a serial communication standard. Now we can go through the parallel communication standards. The parallel communication standard is a method of transmitting multiple binary digits simultaneously through multiple communication channels. In the first figure, it is showing the parallel communication standard, and the second figure, it is showing the serial communication method. In the parallel communication method, we are sending multiple bits of data simultaneously through multiple communication channel, and this communication channel can be multiple wires. And since it is the data is sending simultaneously through multiple wires, the speed will be higher in the case of parallel communication. And for serial communication, we are initially serializing the data, and then we are sending the data through same communication channel, one bit after another. And here, in order to send 1 byte of data, we need 8 clock cycles. But in the case of serial communication, in order to send 1 byte of data, we only need 1 clock cycle. So serial communication standard is inherently slow. This parallel communication has many advantages and disadvantages. The main advantages of parallel communication is that it is faster, because we are sending data through multiple communication channels simultaneously. So basically it will be faster than the serial communication standard. But there is a catch. It means that we cannot increase the frequency of the parallel communication more than a limit, because when we increase the frequency of the parallel communication, the clock skew and synchronization issues come into action. So it will limit the speed of the parallel communication to a particular frequency. And another advantage of parallel communication is that it is very easy to implement parallel communication standard, because there is no serialization method needed to be implemented. So hardware and software will be simple. But along with these advantages, this parallel communication has a lot of disadvantages. And one of the disadvantages is crosstalk. Since we are sending data simultaneously through a multiple communication channel, and this channel probably will be pairs of wires. Since these wires are arranged very near to each other, there will be good chance to happen crosstalk. And this parallel communication is probably a half duplex communication, because in order to implement a full duplex communication, we need double the number of lines which is used for half duplex communication. For example, if the parallel communication standard is implemented with the help of 30 pairs of lines, and if we need to implement full duplex communication, we need 60 pairs of lines. So it will be very difficult to allocate that much line for full duplex communication. So the parallel communication standard probably will be a half duplex communication method. And in order to implement a parallel communication, we need multiple communication channels. And in the case of if we are using electrical wire for communication, we need multiple electrical wires. So it will be for long distance communication, it will be costly. So for the long distance communication, we will use only the serial communication. And the connectors also used for the parallel communication is bulky, because we need to accommodate all the communication channel for these connectors, and it will be bulky, so it cannot be used for some application where we need a long form factor. For example, we cannot use it in our mobile or some small development board, etc. Now we are moving on to ISA standard. ISA stands for Industry Standard Architecture, and it is used for connecting the processor with various peripheral devices. And this ISA is a parallel communication standard which is developed by IBM in 1981, and they have developed an 8-bit version of this ISA standard in 1981, and this is developed for their PC. And later they have developed a 16-bit version of this ISA standard for their newer PC, IBM PC-80, which was used an Intel 80286 processor. And since this standard was developed for this IBM PC, this ISA standard is originally referred as IBM PC-80 bus, and later they have renamed it as ISA bus. The 8-bit version of the ISA standard can provide up to 4 megabyte per second speed, and it can support up to 1 megabyte of memory, and it contains 62 pins in the connector. And 16-bit version of the ISA standard can provide up to 16 megabyte per second speed, and it contains around 98 pins, and it is can access up to 16 megabyte of memory and 64 kilobyte of IO address space. Microsoft rolled out first of its graphical user interface operating system, Windows 1, in 1985. But this ISA bus is not good enough to handle the bandwidth requirement of the many of the graphical application. So a group of graphics card manufacturers comes together and create a bus, and it is called as VESA local bus or VL bus. But this VL bus is tied to the 80486 CPU, so it cannot be used for the later Pentium CPUs. And later IBM also created a new bus architecture called MCA architecture. MCA means micro channel architecture, and it is CPU independent alternative of this ISA architecture, but this also not went too popular. Now let's go through the various features of ISA bus. ISA bus can contain 8-bit or 16-bit data lines, and it can support up to 6 devices. and it is operated at typically 8 megabyte per second, and it is but it is not hot pluggable. It means that it doesn't support a plug and play feature. Here this is an IBM motherboard. Here you can see that there are 6 16-bit ISA slots and 2 8-bit ISA slots. Here you can see that there are 5 16-bit ISA slot and here one 16-bit ISA slot. So total of 6 16-bit ISA slot, and here is one 8-bit ISA slot, and here is another 8-bit ISA slot. So total of 2 8-bit ISA slot. During the time this USB and PCI protocols are not developed, so this motherboard only has this ISA slot for communication. Here you can see an ISA connector. An ISA connector has some lines of the ISA connector is reserved for address, and some lines of ISA connector is reserved for data. And here this is an example of 16-bit ISA bus. Here you can see that there are 32 connectors is reserved for address, and 16 connectors are reserved for data, and some connectors are reserved for interrupt request, and some other control lines also there. And along with this data and control lines, there will be, you can see there will be some power connectors are also there, and a total of 98 connector will be in an ISA bus. In order to improve the ISA standard, a group of some third-party clone vendors, PC clone vendors, created a standard called Extended ISA, which is developed in 1988, and it supports 32-bit data. And all the configuration of the Extended ISA can be done using software. It means that there is no IRQ or DMA jumpers needed, which was and it was needed in the case of ISA standard. But it is not become popular. But many of the server system was switched to EISA standard. After ISA, next breakthrough in the peripheral communication standard is PCI standard. The PCI stands for Peripheral Component Interconnect, and it is a parallel communication standard for connecting various peripheral devices to the processor. And this PCI standard is developed in 1992 by Intel, and later it is maintained by PCI Special Interest Group. And there are a lot of peripheral devices are built using PCI standards, such as network cards, sound cards, modem, TV tuner cards, and disk controllers, etc. And recently, nowadays, this PCI standard become obsolete, and it is superseded by PCI Express. It is a serial communication standard. PCI contains 32-bit data lanes, and it is operating on 33 MHz. So we will get an effective bandwidth of 32 into 33 megabit per second, or 133 megabyte per second. And it also supports 64-bit implementation. If we use 64-bit implementation of the PCI, we will get 266 megabyte per second data transfer rate. And it also supports full plug and play. It means that we can directly attach the peripheral device to the PCI bus, and we do not need to do any configurations, and all the configuration is done automatically using the software. The main feature of PCI is that PCI support plug and play feature. Using plug and play, the operating system can easily detect and configure the peripheral devices without user interaction. And in order to implement this plug and play feature, the peripheral devices contain some configuration registers, and this configuration register contain some parameters about the devices, such as device type, device ID, device manufacturer, device class, etc. And using this configuration register, the operating system can detect and configure the peripheral devices. And the PCI bus contain 32 or 64-bit data bus and 32-bit address bus. And in order to reduce the number of connectors in the PCI bus, this address bus and data bus are multiplexed. Now let's go through the PCI bus specification. The PCI bus contains 64-bit address bus and 64-bit data bus, and both buses are time multiplexed because we are not using data and address buses at the same time. And along with this multiplexed address and data bus, the PCI bus also contains system bus, interface control bus, parity bus, error bus, interrupt bus, JTAG, serial bus, etc. And this JTAG bus is used for testing, and it also contains power supply with plus 5 volt, plus 3.3 volt, plus 12 and minus 12 volt, and along with ground. Let's go through the basic diagram of a PCI architecture. Here you can see that there are two PCI buses, PCI bus 0 and PCI bus 1, and there is one ISA bus also. And a CPU and the video card is connected to the PCI bus 0. And in order to attach another PCI bus, we are using a PCI to PCI bridge, which it will use for connecting another PCI bus. So using PCI to PCI bridge, we are interconnecting PCI bus 0 and PCI bus 1. And in PCI bus 1, we are connecting other peripheral devices such as Ethernet and SC, SI, etc. And for connecting the ISA bus, we can use PCI ISA bridge. And here we are using a PCI ISA bridge to connect to an ISA bus. And in the ISA bus, we are connecting the ISA peripherals. Here you can see that basic pinout of a PCI interface. Here there are some required pins and there are some optional pins. And these optional pins need not be implemented by the PCI peripheral devices, but the required pin should be implemented in order to connect to the PCI bus. And the required pins consisted of some address and data lines. It includes a multiplexed address data lines and a command or bit enable input and a parity line. And along with this address and data bus lines, it needed interface controls and error reporting and system bus also needed. And the optional pin include some testing pins like JTAG and some interrupt pins, and then address and data bit extension lines. Now we can go through the various registers present in a PCI standard. We know that PCI support plug and play feature. It means that if the peripheral devices attached to the system, the processor can easily identify and configure the device. And in order to achieve this plug and play feature, the PCI peripheral device contain some configuration register such as device ID, vendor ID, status, command, class code, etc. And along with this configuration register, it also has some address register, and these address registers such as base address register is used to do a data transfer operation. Here you can see basic timing diagram of a PCI standard, and here there are many signals like clock signal, frame signal, multiplexed address and data signal, command and bit enable signal, initiator ready signal, target ready signal, and device select signal. And for the performing a data transfer operation, we will have to send the address. Then we will send the data through multiplexed address and data line. And during sending the address, we will also send a frame signal to indicate that it is the start of the data transmission. And also we are using the command and byte enable signal for selecting address and various and data values. In this motherboard you can see there are some PCI slots and some ISA slot, and this is the ISA slot. There are 4 ISA slots in this motherboard, and along this 4 ISA slot there are 4 PCI slot also we can see in this motherboard. And from this figure we can understand that PCI slot has low form factor than the ISA slot. We know that the PC supports speed up to 33 MHz, and this 33 MHz is not enough for many applications such as gigabit Ethernet and fiber channel. And in order to handle these high bandwidth devices, the PCI Special Interest Group has created PCI Extended or PCI-X in 1998. And but this was not become popular in desktop applications, so it is mostly used in servers and workstations. And this PCI X 1.0 can support a clock up to 133 MHz, and PCI version 2.0 can support a clock up to 533 MHz. But this is become replaced by later PCI Express, which is a serial communication standard. PCI X supports 32-bit and 64-bit address lines, and it can be used with 66 MHz to 533 MHz clock frequencies. And if PCI X is used with 64-bit address lines and 533 MHz clock frequency, then we can get up to 4 Gbps bandwidth, and we cannot increase the frequency from 533 MHz due to the problem with the clock skew. PCI X standard has mainly two versions, PCI X 1.0 and PCI X 2.0. PCI X 1.0 is developed in 1998, and it can run clocks with clock speed up to 133 MHz. And PCI X 2.0 is developed in 2003, and it is supported 266 MHz and 533 MHz, and it also added features for error detection and correction in the data transmission. Here you can see the connector structure of the PCI X standard. In the first one is the 32-bit version of the PCI X standard. Here there are only 32-bit data lines, data bus lines. So the PCI number of electrical connection in the PCI connector will be small, so the overall length will be small. But in the case of 64-bit data bus lines, the length of the PCI connector should be higher, because it need to accommodate higher number of data bus lines. PCI standard is superseded by PCI Express standard. Here you can see that the constructor structure of PCI Express and PCI, and PCI Express has small form factor than PCI. Thank you.